Hello, everybody. Welcome to our webinar today. Today we are going to present the essential tools for your data connectivity toolbox. It will be presented by Darek Komeniak, our Senior Consulting Manager for Matrikon. Just to remind you that you have this Q&A tab, so you can write here all the questions that you have, and it will be answered at the end of the seminar. So I will leave the word to Darek to start the webinar. Thank you all for coming.
Great, thanks. Thanks, Eliana. Hello, everybody. So as mentioned, I'm Darek Komeniak, and I'll be walking you through a topic that I find comes up fairly often when we're dealing with various customers on just really basics of data connectivity, but nonetheless, these basics are essential to setting up a proper infrastructure for communications. So what I've done is put together basically just it's a short presentation, but it talks about sort of three keys or pillars, if you will, for what I see people require in different scenarios. So number one is just overall reliability and security of their data connectivity. This can be real-time data or historical data transfers. It can also cover situations in the plant or basically on-site where you're just trying to communicate between systems locally, and that has some of its own challenges, or you're trying to talk remotely with remote systems, which actually, of course, increases some of the challenges for guaranteeing, for example, that you receive the data or even to establish the communications with those systems. So I'll talk about reliability and security, and as I foreshadow here, the particular product that we have that actually helps to address this, and again, this is meant to explain what it does for you, is Matrikon OPC Tunneler. We talk about local buffering, so the ability to capture and access information on-site, wherever that may be, and whether that's, again, local or in a remote destination area. We'll talk about that. And also about guaranteed delivery, which should be contrasted to redundant solutions where you're typically dealing with real-time data and ensuring that you have no real-time data loss. So guaranteed delivery focuses more on the historical side where you've already captured the data and eventually you have to ensure that it actually still arrives, for example, at a central location. And for that, we'll be talking about HistoryLink. And then, of course, we'll have some questions. Okay, so to get started, so the first challenge, like I said, is just dealing with secure, reliable data access. And what I show here is basically a scenario where you might not have all of this, but in the center we've got various OPC servers running, communicating with either devices through various native protocols, be they serial or over TCP, or you're talking to controllers. Sometimes you need to talk between them, etc. And as well, you may also have remote communications. Now, whether you're using a satellite or microwave, or there's a whole slew of different technologies that you can use to communicate remotely. But that, of course, generates its own challenges. Okay, so for real-time data connectivity, number one, security is essential. Now, if you're using OPC, and just to be clear, there are two generations of OPC that are out there right now. So I'm referring to what we call now classic OPC, and that's basically sort of from its inception going forward. OPC has been based on the overall Windows infrastructure, which also includes using what's called DCOM, Distributed Component Object Model. And basically, for if you're not into all the details of how the Windows OS works, DCOM is basically the mechanism that Windows uses to share data amongst its own objects and also to share data between applications either on one computer or multiple or networked computers. Now that's fine for office type situations, or at least it used to be. And now, of course, as we move on, DCOM has become a bit of it's become a bit of an issue when you're dealing with security, for example, because not only does it facilitate communication between applications, but it also has hooks right into the operating system. So when either malware or hackers are trying to get into a system, this is the thing that they attack. So IT is very cautious about it, and of course there are firewalls that are implemented, And also, even when you're trying to communicate between domains, you are tied to the identity of the user who is logged into a particular system. So if you're working across domains or even different work groups, the DCOM communications by default would get shut down because there is no trust established between those systems. So whether it's just the user integrity or someone's actually trying to hack in through the different ports that DCOM uses, because it uses a number of them, that often will create issues when you're trying to deploy an OPC solution. Now, as mentioned, there is a second generation of OPC now, and it's gaining adoption in the market quite rapidly, thanks to the, obviously you guys probably have all heard about the IIoT, the Industrial Internet of Things, or Industry 4.0. So it's a much more robust version of OPC. However, the reason I continue to talk about the solutions that we provide for classic OPC on top of, let's say, the solutions that we have for OPC UA, which is the next generation, is because the majority of the infrastructure that's out there right now talks classic OPC. So as we go forward, I'll have actually additional webinars that I'll be holding about running phase migrations and such as companies start to shift towards using the latest and greatest. But for the purpose of this presentation, I'll be focusing on the classic solutions because, again, the majority of people actually still have this in their infrastructure, and they're not keen to rip and replace it for the new technologies that are coming out. So in going forward then, when you're dealing with DCOM, you also have to then contend with various IT departments and with the firewalls they put in, et cetera. And you have to also deal with some of the ability to talk across different domains and also to protect the data. DCOM itself, or the classic OPC, doesn't have encryption of the data. So if you're transmitting remotely or even on your network, that information is not encrypted. And security by obscurity is long gone. That's a myth that's been busted. So when we talk about reliability, that's another thing. DCOM, again, is good for sending documents to the printer and having local communications. But basically, if you connect across the system and some of the connection goes down, or there's a loss of connection for some reason between the let's say, client and server that are communicating, then basically DCOM does not discover that potentially for 6 minutes or longer, because there are different timeouts that are built into the operating system. Again, there are historical reasons for that, but in the end, when you try to apply it to industrial systems, that can have some serious consequences if you're flying blind for a while because the underlying system doesn't recognize that a disconnect happened. And then, of course, there's a question of reconnection, which means, okay, well, let's say that you time out and the client, I show an OPC client in gray at the top there, is communicating with one of the servers down below, or all of them. And now the question is, if you lost that connection down at the Windows level, let's say where DCOM communicates, how do you reestablish? The client has to recover from the fact that communications were lost. And it's not relatively just as simple as, having dealing with it at a protocol level where basically you just need to reconnect. It goes a little deeper because, again, it's sitting on top of the operating system. So those are some of the things that cause some of the reliability to go down as far as the connection is concerned for OPC. And then the other question is, if you are transferring data from remote locations, a lot of times there's a higher cost for the data transmission. So if at all possible, you'd be looking to reduce the expense of doing that. So these are the typical issues that people right now, when we deal with them on a day-by-day basis, come across. So when you start to put in, for example, the firewalls, they will lose connections there unless you start to open the firewall up. The problem there being is that, again, if the firewalls are being put in to limit access to ports, which people could potentially hack or systems can get through which shouldn't, then of course you also start shutting down the DCOM ports because the underlying DCOM communications are what gets attacked. And yet, if you need communications with the OPC server, well then, of course, there's now a struggle between operations and IT because one needs the data, the other needs to keep the system secure. So that generally causes issues. If you create another domain, because you're putting things or you're talking across different domains, again, that causes issues if you're using straight OPC. And of course, if you get some kind of atmospheric interference or all sorts of issues that can come up, well, then you also lose your connectivity remotely. Now, we can't control the weather or things that will get, that will cause interferences for the transmissions. But what we can do is we can affect how the system responds to that physical loss of connection, and at the same time how it recovers afterwards when the system does come back up. So in this case, as I mentioned, we'd be talking about OPC Tunneler. OPC Tunneler is basically software that sits both on the client side and on the server side. So in OPC, you have a client and a server which communicate. The client is typically built into the application, so it natively knows how to communicate with all sorts of OPC servers, regardless of which vendor they come from, which is the main selling point of OPC, is the fact that you have vendor-independent connectivity. Because basically, if you have a OPC server that is compliant with OPC specifications, then any OPC client that is also compliant with those specs is capable of talking to it and actually getting the data from it. So when we put the OPC Tunneler components on the client side and on the server side, what happens is Tunneler uses its own method of communicating between the Tunneler components, which do not rely on DCOM. You're talking about straight binary data being transferred over TCP/IP using a single port, which IT can identify what that port would be. So in the first instance, when we talk about security, because we have eliminated the need for DCOM, we no longer need the DCOM ports to be open, which the operating system continues to use. At the same time, when we have a single port and it's using now dedicated OPC communications, so unlike DCOM, which can be used for all sorts of additional operating system functionality, the tunneler traffic that goes over a port is only intended for communications or sending OPC data back and forth, which means that over the years now, because we've been basically providing OPC Tunneler for, it's got to be over 10 years now, the IT departments do not have an issue working with Tunneler because they can understand what it does and how you control the, what the destination and the source are and what the traffic is used for. In addition, Tunneler also includes data encryption, which means that not only are you sending standard OPC traffic, at the point of, let's say, from the source where the OPC server is, and you're receiving OPC traffic at the client, but in between, that data is actually encrypted. So you're now adding that layer of security on top of the fact that you're actually working, let's say, positively with the firewalls that you have to traverse. Okay, so that's definitely a strength. Now, when we talk about reliability, because we are not relying on the DCOM mechanisms built into the operating system, we have our own way of detecting whether a connection is lost or not, right? So when you're talking about a straight protocol and you have two components that are basically communicating with each other, they very quickly can determine that, right? Because you're basically running directly over TCP/IP. So we detect the loss of a connection very quickly, whether that's locally or, again, if you have remote communications. And not only do we detect it, but even more importantly, it's what we do with that afterwards, right? So in OPC, if a client loses connectivity with the server, well, then you would have to reconnect to the server and make sure that your configuration is back up, and then you have to reestablish the communications with that server, which is, there are time delays with that, and also depending on the complexity of the server or the client that you're dealing with, that may actually have a not such a simple sequence of events that you have to follow within your process in order to ensure that everything smoothly reconnects and continues to run. So to avoid that, what we do is the Tunneler connector, which, again, if you think about it, it's kind of like a hose, right? Like a hose you'd have at home. It doesn't matter what the hose is made of. What matters is that the end points of the hose, you have standard connectors so they can connect it to any house faucet, and on the other side you can connect it to any other type of device, a compressor or your sprinkler or whatever, right? So the same way for Tunneler, the technology that we have built over the years for securely transferring the data between the endpoints That's what we take care of, but on either side, we expose the data as OPC. So any third-party component, server or client, can utilize Tunneler to actually establish that secure, stable link between, across the network. Now, if connection is lost, for example, like I showed in the last slide, you get interference connecting to a remote site. What happens is that Tunneler endpoints understand that, okay, we were connected, connectivity between those two points was lost, and therefore on the client side, Tunneler will indicate that yes, communications have gone bad, but it does not disconnect. Therefore, the client, as it runs, actually continues to assume that it is connected to the endpoint, the source. However, the data is bad. So for all functional reasons or for practical purposes, the behavior of the application is still maintained. So the integrity is maintained, right? If you are aware that there's a problem with the communications and, for example, can indicate there's a communications failure, but you don't actually lose the connection, the underlying systems, because that's still operating as an OPC client. Now, once the connection physically is restored, so now the Tunneler client side can communicate with the Tunneler server side. Now they establish communication back with each other, and when they're ready, Tunneler on the client side will now indicate that, yep, connectivity is back up, data good, and the values start to be transmitted again. What that means is that both the server on the server side and the client on the client side don't actually experience the connectivity going down. They just experience the fact that the data has gone bad, or that the connection between them has gone bad, but it's just a data value. It's not an actual disconnect. Okay. Now, the other important part to that is that Tunneler will actively try to reconnect with itself, right? So the components will not just sit passively, they actually try to connect. Obviously, I'm not going to go into a lot of detail on all the functionality and the settings in the application, but there are a lot of scenarios that one has to contend with. So for example, what people don't want is to have the components spamming their local network because they're trying to reconnect all the time, and therefore eating up bandwidth. So you can configure, how fast and how many times Tunneler will try to reconnect. But the point is that the software will actually allow you to reestablish that connection automatically in the background without affecting your client and your server. As a final point on this slide, when you're transferring data, you can also optionally select for Tunneler to compress the data. We achieve roughly, let's say, a 30% data compression. So that may not sound a lot if you're just sending a few values, but if you are communicating with remote stations and you have a lot of data to send, that actually starts to make a difference. Okay, so that's something that you have as an option. All right, so that covers sort of trying to allow whether it's local or remote communications to be more secure, more stable, and also to reduce the amount of data that's actually getting sent through, so reduce bandwidth use. Okay, let's talk about the next one. So ability to capture history and then also to be able to access it. So when you're generating data locally, of course you can connect and you can see the live values that a server is exposing. But at the same time, you sometimes want to have the ability to, of course, see what's been happening, right? When something goes wrong, the present value is important, but what's even more important is what led up to it. And therefore, whether you're doing this locally or you're doing it remotely, having the ability to actually capture that data is important. Okay, and again, then there's a question of security. So you want to have sort of one source of truth. So when it's being captured, everybody sees the same, let's say, historical files or historical values. And you can also ideally control who has access to those historical values. Sometimes we deal with offshore platforms where, for example, you'll have multiple partners working on the same, being co-owners of the platform, and they have some sensitive data for each of their operations, and they don't necessarily want to share it, but they do need to have it all captured. So being able to segment and isolate, which data, which partner is able to access, so everybody gets, access to the information that they are privy to, but not the other partner's information. That's very important. So being able to manage that is a key aspect in some situations. And then, of course, keeping the cost to a minimum. And that would apply that, everybody is aware of enterprise-level historians, but you don't always need enterprise-level historian for all the applications, right? So it's kind of like shooting a cannon at a fly. Sometimes you just don't need that much functionality built into it with all the aggregates and long-term data retrieval and such. You might be just using the local data on a shorter time span, or just the way you consume the data doesn't require so much infrastructure. So, and of course, the cost that's associated with that. So in this case, what I would bring up then is that the fact that Matrikon offers something called the OPC Desktop Historian, or we just call it ODH for short. And this is basically what we call a field historian. So it captures data very quickly. It does not compress the data. So basically, it's not doing a lot of processing on it, and therefore, basically, you just capture the data as it comes. It's purely OPC based, so you can, it acquires data through OPC, and it also exposes data through OPC. So whether you're trying to pull real-time values into it, or you can also extract the values as they come in. So we call that near real-time, because first that has to get captured into ODH, and then its built-in server can expose the data in near real-time. But then, of course, you can also just connect to the source itself if you need pure real-time. On top of that, you would extract the data, the historical data, by using OPC HDA. So that's the historical part of the standard, which stands for historical data access. And not only would you be able to pull that in through an OPC source, but we realize that sometimes you'll have devices that will basically spit out files or update files. So there are different strategies that they use, and they would basically write that to some location in the network. Typically on a PC, they'd be storing it in a particular directory or multiple directories. And basically, as the file gets updated, it changes its timestamp or its size changes, and that's how you can detect that additional information has been added from a device. So desktop historian being meant for sort of field devices or these types of shop floor applications, it also has the ability to pull those that data in from the basically flat files, so CSV files, comma separated value files, and you can identify the rules for how what that format would be, because they're not all the same. So whether you're using that locally, the ODH has the ability to run multiple instances, so you can scale it, you can run it in a virtual environment, or you can also, of course, use it remotely, and there are different modes. So whether it's used more as a buffer, so basically sort of that concept of a circular buffer, therefore you have zero maintenance because you identify how much space it's going to take, and it basically just continues to capture data for the amount of time that you would like to have history for, and then it basically just overwrites it. So therefore you don't have to do maintenance on that installation. It just continues to run indefinitely. So that's sort of the purpose for ODH. So key thing is that you want to provide local access. So if you are at a remote location and you want to have, for your maintenance people or for the engineers and such, if you want to have access to what's been happening locally without having to access that information again using your remote communications to pull the data in, saving on bandwidth and even the just the convenience of being able to have that data more immediately, ODH is a small enough let's say investment that that becomes easily something that you could deploy at a remote location. Okay, so, and you can then, of course, depending on how you set it up, you would use it either locally or you could also access that remotely. And again, this dovetails well with using the OPC Tunneler. So if you need to ensure that, you've got all the security built in and the stability, you can also have that sort of layered approach. Okay, as I mentioned, there's a flexible file import functionality, so it'll monitor the status of the file and therefore it'll continually update it if that's the only way to get data from a particular device. Okay, as far as security, the ODH application itself, as all Matrikon applications do, it implements security fully. So once the server on board of the application identifies who the user is who is connecting, you can define as an administrator what information will be provided for which user credentials. And you can identify basically, and this is again in general for all our products. So who can browse what data? So if you connect, what tags will be exposed to you? So rather than, for example, exposing all the tags to everybody, the items that are stored, and then basically just denying them the right to see certain ones, it won't even show them the ones that they don't have access to or rights to. So therefore, it keeps it nice and simple and clean for the different parties or different people who will be accessing that type of data. And you can control what we say per user per tag, access control, so whether that's browsing, reading, or writing. Right? So it's much more granular than what, let's say, what typically you see in OPC implementations, where basically, yeah, you can decide whether somebody can connect to that server or not, but once they do, it either does it at an application level, which is more of an IT approach, right? Can that application read or write? That's sort of the granularity that you achieve when you're using DCOM, or you can go much deeper by using those credentials and having the software actually maintain the security, which we do. Okay, so being priced as a field historian, this is one of the distinguishing features, that basically you have all the connectivity. Again, it communicates with all the third-party systems that are using OPC. It also exposes that data for third parties, of course, as long as they're authorized to connect. Yeah, they have to authenticate. Yeah, it's an easy solution to deploy. All right. The third scenario that I want to talk about is just overall guaranteed data delivery. So once you have this, once you've captured the data, let's say at multiple locations, whether they're pump stations or power stations, whatever, something along the pipeline, or even different plant locations, you typically want to centralize this. Now, that might be all on the wired network or on the LAN, or maybe you're actually, again, communicating remotely, so you're using some sort of remote communications. And now, of course, you need to centralize this. Okay. Now, in some cases, that's because that might be regulatory requirements or safety. Sometimes it's purely for performance or actual output. There's a myriad of reasons of why you need to do it, but in the end, typically you want to bring that data together. Now, of course, if we were to tie that into today's sort of push to move towards big data, or sort of putting information into the cloud and such, whether you're continuing to use your centralized historian and you've already got that infrastructure in place, or you're going to go directly to cloud, well, those are some additional options now that are opening up and people are exploring. But in the traditional sense, you still need to somehow bring the data together so that you can start working on it across a broader, across the entire, let's say, operations of your enterprise, as opposed to just spot checking each individual location. Okay, so the important part there is that it's inevitable that eventually you do get connectivity breaks between, let's say, central store and the remote locations. So the question is, the point is, you cannot have that mean that now you lost the data that was available there. So as in the last slide, number one, you would have to collect data typically at the remote location to ensure that you have that history at least locally captured. That would be the prerequisite. And then the second step is, so what's going to implement the logic to actually transfer and to know when to transfer the data from a remote side to your central location. Now, sometimes that may sound quite simple, but if you look at how, for example, enterprise historians work, quite often they don't handle data well, which is out of sequence. So if you have a disconnection and you didn't transfer a bunch of information, and then when you reconnect, you of course start to receive the real-time values that are presently current, and at the same time you start sending past information over, that can, let's just say, cause some indigestion for the historian, or data corruption and such. So having a proper method of transferring the data in a way that is digestible by the historian is important. And again, it doesn't matter whether you're using an enterprise historian or an ODH, or other type of or relational database, for example. Eventually, you're trying to store it centrally. Okay. So data migration is another aspect. When we're talking about managing historical data, you don't always necessarily have the challenge of just trying to centralize it from other systems and continually feeding it into, sort of on an ongoing basis into a central store. Sometimes you're actually trying to exchange the central store, or you're moving from one enterprise historian to another one. You're shifting strategies, or maybe you had an acquisition and you need to switch from one system to another. Again, a lot of different reasons why people need to switch sometimes, and that's not trivial. So, if you've ever done a, switch over from one CRM or going from Outlook to another system, and you're trying to, transfer your address book across, you even see that that is not trivial. When you're trying, there's a lot of different parameters that have to line up between systems and how they historize or how they arrange the data. So when you're dealing with historians, it's the same thing. There's a lot of information stored within them, and if you do need to do sort of a shift over to something else, how do you extract all the data that you have from one and move it into the relevant data into the second historian, for example? So that's a challenge that people typically end up writing scripts for, or they outsource, or they hope that there's a competitive tool that allows them to move from one system to another. But there's actually an easier way, and I'll cover it right away, and it's all, again, based on OPC and some logic, some advanced logic that sits sort of between those two systems. Okay, and then another aspect is that if you are trying to archive data and send it over, a lot of times, things are pretty mundane. Everything is running as it should, so you don't need to have very high sampling rates on what's happening because it's just continuing to run as it should. So the values aren't necessarily updating or changing very rapidly, and therefore everything is sort of status quo. But when you have a disturbance or an event occurs, things start to happen quickly. Something goes down, all sorts of auxiliary systems start to kick in. A lot of additional information is available. But the question is, do you capture it? Does your system, does it have the ability to detect that something has changed and, for example, accelerates or captures more high-speed data, high-resolution data, so you get a better, more granular view of what led up to the event, and then, as the event settled down, how the resolution went. That's something that's useful, but of course doesn't happen by itself. So for this type of scenario, what we have created, again, years ago is called Matrikon HistoryLink. And what HistoryLink does is it's basically a management tool that you put at the typically remote location where you're going to be collecting data from, or you want to move that data from point A to point B. And it has various functions that it fulfills. So number one, it's an essential tool for doing data centralization. So as shown in the diagram, if you're at a remote location and you want to move that data, you want to centralize it at the central store, this is what HistoryLink would do. It will not only, you identify which, of course, values you want to move, and then it will monitor what's happening with the connection. And if you lose the connectivity, it will, of course, keep track of that. And when you regain the connectivity, it will then start to send the information that was missed during that time period to basically offer a backfilling type service. Now, a lot of times when people talk about disconnections happening, the loss of connection, people imagine that you'll have a break, and then there's silence, and then you connect, and then the data starts to flow again. But in reality, what happens is a lot of times, I'm not sure if you guys ever talk on the cell phone, and you're kind of losing the connection, and then it's kind of up, and then it's down, and then it's up again, and then either it recovers, or then you finally lose it, and then you have to recall somebody, reconnect with them. Well, the same thing happens with these communication systems. So what one of the strengths for HistoryLink is that it actually monitors what's happening with each transmission, or constantly monitors what's happening with that connection. So even though you may have a series of disconnects and connects, or at least communication losses, and it regains them, it actually monitors all of that and takes that into account. So it's not just a simplistic way, let's say, of saying, if you lost the connection, then it came up, we transfer it. It actually actively monitors what's happening with the connection, and it performs that backfilling service relative to what's been happening with your connection. Okay, so we've been using this for years again. So we have a lot of experience with this, and it's a very popular solution for people who are trying to create what we call a hub and spoke solution, right? So hub being the central store, and then the spokes are basically the sites, the remote locations feeding into the hub. And HistoryLink is the thing that that powers that. Okay. As well, if you want to use, logical extension, if you want to transfer data from all the data from one historian or data source to another, you can also use HistoryLink for the same thing. You just identify that you want to grab the entire time span, and it can just sit there and work through and actually transfer all the values. And we've done this for thousands of gigabytes in some instances, from one system to another to basically populate it with the data that used to sit in the other system. Now, the types of information that this transfers, well, of course, we're dealing with OPC, so this is time series data. So, but it's using HDA, so historical data access again, because we grab blocks of data and, chunk by chunk, it transfers the information over. As well, HistoryLink also does allow you to move this data to and from CSV files. So again, depending on the destinations and the sources that you're dealing with, it's flexible enough to also work with that. Another key feature that I'll mention here, and again, it's not that you would use all the functionality necessarily. There are just different capabilities that surround the same topic, which is just dealing with how historical data is managed and delivered. But so the third one that I wanted to touch on is event-driven transfers. So you can identify in HistoryLink what sorts of things you want to be monitored, which aspects, which tags, what values. So you can, for example, cause a trigger to transfer certain values from your local historian or your local store to central. So whether that is, you, for example, use an indicator of when a batch has changed, and therefore you want to take all the information that just finished running and transfer that as a block, and then continue to work with the rest of it. Or perhaps, at a certain time of day, there's less traffic on the network, and that's when you would like to have transfers happen. You would generate that type of event, but basically identifying a tag that you set up to indicate that now is a good time to transfer the data, etc. It can do that. Now, as I mentioned, if you have a situation where locally you are able to historize higher speed data, or basically data at a higher rate, but you don't necessarily want to transfer all of that data across, because typically you don't need all of that because not so many things are changing. What you can also do is monitor, and if a particular event happens, let's say there's a trip, something occurs where now there is a issue, since you have the local data saved continually at a higher rate, what HistoryLink can do is grab data from before X amount of time before the trip that happened, as it was monitoring for that type of event, and after, and it can transfer the high-speed data just for that range, and then return back to transferring data again at a lower rate. So what that means is that basically effectively you are getting more data surrounding the event, and then you return back to the typical update rate of data that you were collecting once that event passes. Okay, so it just gives you a way to better control how you're transferring that historical data. So to go over this sort of as a recap, as a functional summary, as I call it. Number one, we talked about connectivity. So when you're using Tunneler, it allows you to securely connect between systems, and it also ensures that that connection stays, number one, can be established when you're talking across more complex networks, whether that's with firewalls or different domains, and also reconnect automatically. Then next, we talked about local storage, whether you're taking information that's typically saved in just flat files, which can inadvertently be overwritten or can be changed because there's not much protection on that. Or you're actually even taking data from a historian and you'd like to transfer it. We talked about how you would do that with ODH. We talked about forwarding with HistoryLink, which would allow you to move data into a central store. And again, whether you use our own product or you're using a third-party historian, that is purely up to you. That's the beauty of OPC and why Matrikon, embraced this technology, is because you want to be independent. We don't want you to be locked into any particular vendor's solution. You can choose the best fit components as you see fit. Okay, so that's what we talked about, or I talked about right now. So as we go through this, there are really some questions that you can ask yourself or your team when you're looking at different scenarios, right? So if you're talking about just connectivity in general, the number one, do you need to connect? Are you connecting clients and servers? If that answer is yes, then now the next question is, well, what does your network look like? Are you going to be talking across different domains? Do you have different firewalls? Do you have different users who may or may not be on that domain? How are you going to work with them? Do you need to protect the data? Is there a need for data encryption in your particular application? There may or may not be. And also, is the data compression aspect important? How much are you paying for your data transmissions? Do you, is lowering the amount of data that goes through without losing the information that needs to go through? Is that something that's important? For storage, again, do you need access to it? Are there, for what type of purposes? Is it regulatory, accounting, maintenance type? What's the motivation for it? How are you capturing it today? Are you putting it into flat files? Are you using a historian? What's the solution today? What's the long-term view? What's your strategy for that? And also, does it need to be guaranteed, right? So, for example, will you need redundancy? There's a lot of products, by the way, that are used in various combinations that Matrikon offers to give you sort of a whole solution. I just touched on some of them, but for example, redundancy might be very important for you, especially if you're dealing with regulatory, environmental type situations, and that's something to consider as well. Anyways, now the question is, are you doing this for a remote site or not? Whether people at a remote site would need access to that history, or is it the fact that it's actually the central side that needs some of that stuff to be historized to ensure that if you're forwarding the data, you of course have that. So if you lose connectivity, you can still fetch the data from before, or perhaps you don't, and therefore you don't need forwarding. That just depends on your situation, right? If you do want to forward, again, are you centralizing? What's your network like? Is it going to go down or not? I mean, if you have a very, very stable network, then perhaps you don't need to worry about that. Do you need basically guaranteed delivery or not? Are you trying to migrate? Perhaps you're forwarding or just moving the data for the sake of migrating rather than continuously forwarding the data. And also, do you need to control when, right? So these are the types of questions that basically what I just talked about, we provided answers for. Okay, so that's really all I'm going to talk about as far as the solutions of working with some relatively, let's say, low-level concepts. And a lot of times your advanced solutions will be built on top of that. But a lot of time people sort of assume that it's just a connectivity that will get taken care of, and yet, as they say, the devil's in the details, and you actually have to make sure you have a solid data connectivity foundation before you start building the more advanced applications on top. Now, there is a white paper that we've published. I put some additional sort of comparisons there as far as what some common solutions are for this type of these types of topics, and therefore some things to consider. So I encourage you to download that if you want. It again touches on these three topics, and then really we get to sort of the next steps, and you have some options there as well. So if you're more of the DIY, do-it-yourself type, or basically you've got the expertise, that's what you're working with, then of course you can download these components yourself and start working with them if you want to see how they work, or you can acquire them if that's what already fits in. Or as well, I'd encourage you, if you're, let's say obviously familiar and expert in the topic that you deal with, but maybe OPC and sort of setting up these architectures, these more advanced architectures, is not something that you do regularly, strongly encourage you to contact us. Okay, so Matrikon, our philosophy is always to work with people when they approach us to understand what is your situation, to provide some solution suggestions, if at all possible, sort of by the information that you can either email us or describe. We can, of course, go further to actually do more of an assessment service and such, but that, again, just depends what you need. There's no pressure as far as whether you know you're going to get something right now or you have to move forward with it or not. The idea is just to at least help you become aware of the options that you have. I head up a group within Matrikon called the TSCs, the Technical Solution Consultants. We support our account managers. So if you are dealing with more complex architectures, or you're not sure, for example, your infrastructure can handle the data rates that you're going to require, or the number of connections that are going to be coming in, these are the things that my team does as a review for the account managers. So there's actually a team of people that are willing to work with you to provide you with sort of the right solutions. If you are interested in reaching out, with that, for perhaps because you are working on a project, or you have concerns about the way things are set up right now, again, encourage you to reach out to us. If you can contact us directly. Let's say if you just write to customercare@matrikonopc.com, we will get back to you, and we'll get the conversation started. All right, so that's the presentation part of my this webcast. So now I guess let's take a look at some questions, if there are some, and that'll be it. Okay. So some questions that came in. Can OPC Tunneler software be used for real-time data acquisition from an external control, monitoring and alarm system without affecting the performance of the original system? What are the data requirements, tunneler options, and connection potentials? Okay, great question. So one key thing to note, tunneler itself doesn't actually, it's not the mechanism that does the data, that initiates or drives the data transfer. It's more of a pipe that allows you to securely or reliably pass the data through. So the question here, the underlying question would really be, what rates can your OPC servers and clients support? So if you're talking to a third-party system, the first question to ask is, are you using an OPC server currently or not? Are you talking OPC to that system? Or are you using basically some other native protocol, whether it be Modbus, BACnet, depending on what your application is? How are you communicating that way? If you are using OPC, then Tunneler can be used to allow you to be able to basically move that data now in a more reliable, more secure way. So so far, when we look at it, Tunneler has been used in some very high speed applications. So a lot of times that really just comes down to sort of what the computing resources in the network environment that you have behind it is, whether that, you'll typically hit that barrier first before you would hit the barrier of what Tunneler is able to support. So hopefully that answers your question. Okay, there's another question. How can I make someone asking how they can make a connection between various components, whether they come from Matrikon or Kepler or other system platforms like Wonderware, all via Ethernet TCP. So that's sort of the nice thing about OPC is that regardless of which vendor the OPC components come from, the expectation is that they all work together, because after all, they should be certified on the same specification. So there are no flavors of OPC that different vendors come up with if they are going to claim that they are certified for providing an OPC solution. So as long as these are, and the vendors mentioned they generate standard OPC type, they expose those types of interfaces. Basically, all of those components can communicate with each other. OPC is primarily TCP/IP based. Now, that can be a little bit misleading, though, because DCOM, which is, as mentioned, is let's say, sort of the higher level mechanism that Windows uses to send communications back and forth between different Windows systems or applications on the same system. But it places some overhead on it, right? There's additional information that's added in. So even though DCOM does travel over TCP/IP, over Ethernet, over your network, the mechanisms that manage that data aren't well suited for industrial type communications. And that's why when we talk about using, for example, the OPC Tunneler, what it does is it actually says, okay, let's not use the DCOM side or the DCOM mechanism, and it actually transfers binary data more directly right over TCP/IP. So in all cases, OPC Classic travels over TCP/IP, but it's just a question of how much overhead you're adding and what dependencies you're building in, whether you're using sort of the vanilla or the standard DCOM implementation, or you're using the tunneler application to sort of strip that away and sort of get to the bottom of it. Okay, another question, what percentage approximately, I'm glad you have included the approximately because that would be hard to tell, of installations globally are using classic OPC versus, now you called it OPC IIoT, so yeah, that's OPC UA. UA stands for Unified Architecture, and I've got other webcasts on that as well, by the way, if you wanted some more information on what, how OPC UA plays in to the IIoT movement, let's say. But basically, it's a fairly quickly moving target at this point, but I would be quite confident to say that 85, if not 90% of all installations today are still classic OPC based. So we as Matrikon are working sort of on a two-prong approach. We not only provide, of course, the classic products, but we also have strongly moved into the UA side of things, even down to the point of creating a OPC UA toolkit that we are actually working with vendors so that they can adopt OPC UA directly into their devices. Because one of the main changes there is that OPC UA, the next generation of OPC, it now can run directly in the devices. So whereas in this presentation, all the OPC implementations I talked about have to run on Windows because OPC Classic by definition runs on Windows, the Windows infrastructure. The next generation of OPC runs everywhere. So our toolkit, for example, allows vendors to put it into small embedded devices that might not even have an operating system, or they have an RTOS, or real-time operating system, or an embedded Linux, or Windows. So basically, it's completely independent of the OS or even the architecture that you're running it in. So that percentage is quickly shifting, and people's preference for using it is sort of shifting with it, because it doesn't use any DCOM. There's no assumption of DCOM because it's not it's not dependent on Windows. So that's quickly shifting. And by the way, because there's such a disparity between, yes, people are moving towards UA, but given 20 years of OPC from the past, there's going to be a lot of deployed infrastructure out there. A key question now is how people are able to migrate. So there is a way, and there are tools that Matrikon provides. And by the way, I'll be running another webcast on that in the coming month or later in April on how you migrate, how you move from OPC Classic, or how you blend those two architectures together so you have an on-ramp towards taking advantage of what OPC UA has to offer without having to rip out their existing classic infrastructure. Okay, next question, how is Tunneler different from OPC UA? That is a very good question. If not, how OPC UA handles the problem described with DCOM. Yeah, so that's a great question. How do you, and it's the right question to ask. And basically, a lot of the functionality that Tunneler offers is actually provided by the way OPC UA, the next generation, it already takes care of the issues that we had to work around in the classic version. So Tunneler, as it stands today, is it's geared towards solving some of the complex problems that were faced by people in the classic infrastructures. And of course, as every company, as we work with UA, we also realize there's value add that we can provide on the UA side, but that's still forthcoming. So if you were comparing what a UA-based solution would give you versus what a Tunneler-based solution would give you, number one, if you're using classic components, then unless you use other types of applications, which are called wrappers and proxies, if you don't get it onto the UA format, then you would have to use Tunneler to overcome the issues that I talked about. But if you're using straight UA components from source, UA server to UA client, basically, number one, UA completely does not use DCOM because the mechanism, so in UA, OPC UA, what's been done is they defined the transport. So the protocols that are used to transport data between point A and point B aren't necessarily the definition of the protocol or the standard itself. So OPC data, which includes data modeling and data security, so the access rights and et cetera, how a client and server establish trust between each other, those are all parts of the standard. But that standard and that data is then transmitted over a transport. So TCP/IP can be considered a transport, right? You can also use HTTPS if you're going to transfer data that way. And now, of course, we're, as additional methods of transferring data. For example, if you're trying to talk to the cloud, you might transfer data over MQTT or AMQP, which are protocols that are geared towards, or transports that are geared towards sending data, into the cloud or basically to a lot of simultaneous clients and servers and such. So kind of more geared towards the IoT space. So UA handles all of that. Whereas Classic, because it was the first generation of OPC, was basically by default just built on Windows and therefore used the Windows mechanisms for transferring the data. And that's why you have a DCOM conversation come from that. All right. Will presentation slides be available? Yes, a PDF version will be made available for you. Okay, somebody asked if I could talk about the redundancy. You know what, that is another bigger topic. Thank you for the question. I would be happy to talk with you about it. And also, guys, if other people are also interested in that, I'd be more than happy to run another webinar on that as well, because that is an important topic. But again, it's out of scope for what we're doing here. The only thing is, I guess that's worth saying is that, yes, you can have redundant communications set up for OPC, but again, you need the right logic to be built into an application that would know how to handle that. But yes, please, we can touch base with you, and if anybody is interested in that topic, let us know. I'll put something together. Okay. So there again, a question about the this webinar. Yep, absolutely, will be available for download, the actual recording. Okay, somebody asks, does Tunneler use a standard protocol? And if yes, can a different Tunneler software be used? So that's a good question as well. So Matrikon developed its own protocol, and sometimes that makes people, they're aghast to hear that there's a proprietary protocol being used, because after all, OPC is all about being open. But again, this is why I use the image of, you trying to choose different hoses to water your lawn, for example. What we have done is we have optimized the protocol and designed one to be flexible for working with, for transferring OPC data from point A to point B. We take care of ensuring that that's done in an efficient, reliable, and secure way from A to B, but we also expose the data as OPC on each end. So the third-party systems that might utilize that, call it data hose, they are not aware that they're using Tunneler per se, because they're just talking standard OPC. Now, if you were asking, well, could you use different solutions? Let's say other companies would have their own tunneling solutions. Well, that would then basically reflect their standards. So unlike OPC, which defines a standard way of forming data or how you exchange the information, this is outside of that, because you would actually basically have to pair the two components up on either side to transfer data in the same way. And it's relatively complex, and we don't share that portion of it. So that's sort of you. If you're going to use OPC Tunneler, you're going to have to use it both on the client and the server side. But of course, the whole point of that is it will work with whatever OPC components you have on those two sides. Okay. Okay, how can you compare Tunneler with a VPN? So that is actually a good, VPN could be, that would be a good, let's say, analogy, let's say, or metaphor to say, well, what is Tunneler like? It's kind of like a VPN where you're establishing a connection between 2 points, and for example, you're securing it and basically establishing that link, and it's independent of what it sort of carries, right? So, but you, for example, could not use a VPN to replace the functionality that Tunneler provides, for the reason that a VPN only provides you, let's say, with a private way to exchange data between points A and B, a secure private way. However, the traffic that continues to travel, let's say you, for example, have the DCOM traffic, because if you're not using Tunneler, then therefore you're using VPN, while you've established, let's say, a secure way of sharing the data, any disruption in the connection would still have the same effect, because in the end, you're still actually relying on DCOM. It's just traveling over a VPN. Whereas Tunneler, what it does is it takes the data and it actually ensures that the transmission of the data and the behavior of the client and server are taken care of. So VPN is more of a IT solution for two systems to talk to each other, whereas Tunneler is a application or OPC-centric solution for clients and servers to talk to each other. Okay. Yeah. So another question is sort of can you bring multiple systems together? So can you, for example, and I'm assuming just that the language that's used in the question, as far as can a single host have more tunnelers? I think the question is trying to ask, can you have multiple OPC servers, for example, going over a tunneled link, and then how is it one-to-many, many-to-one type relationship? And the answer there is yes. On a PC, all the OPC servers that you have exposed or basically running on a particular PC, the server-side component of Tunneler would expose all of them. You would identify which ones you want to have tunneled, and therefore it would then say, okay, here are the servers that are available. So a client side could then connect and actually talk to multiple ones. At the same time, if you're on the client side Tunneler, you can, of course, connect to multiple different PCs and therefore have multiple tunnels or tunnelers providing the connection from multiple PCs to that single client-based PC. Okay, is the Tunneler data transfer encryptable? Yeah, so yes, the data, what Tunneler does, the encryption already. So if you choose to have the data encrypted, then yes, it would do the encryption. Okay, and given that we're starting to go over time a little bit, the last question I'll go over here. There's a question about is there a tool that can convert data from OPC UA to Classic to make it usable by a OPC client, a Classic OPC client? And yes, absolutely, there are such tools. So Matrikon has, there are two components to that. If you have a Classic client, meaning it's using the first generation OPC to acquire data, and you have OPC UA sources, so whether they're controllers or different applications, of course they can't talk directly because the Classic version, again, tries to use the Windows infrastructure. The UA side basically is completely independent of that, and therefore they don't quite talk the same transport level. What you do is you use something called the UA proxy. Matrikon has a Matrikon UA proxy, and what that does is it literally acts like a UA client up front, and then it exposes that data as an OPC classic server out the back, which means that when you install that on the same PC as your client, your classic client, it now starts to see the data in the way it would expect to see it because the proxy does the conversion on the fly. And of course, this also works the same way in reverse. If you have a classic server, but you have an OPC UA client, so a new application that wants to acquire data using UA, but you have an older server, a classic server, then what you would do is you would put in something called the UA wrapper, and what that does is it converts it acts like a UA client to the UA server. Sorry, other way. It acts as a client to the classic OPC server, and then it exposes that data as a UA server to the rest of the world so that your UA client can talk to it. And again, that's basically you drop it in, you identify what servers you want to wrap, and from that point forward, they now can be also connected to via UA. Okay. So that's, guys, I see some additional questions coming in, but at this point, I'm going to have to cut that off. We will respond if I didn't answer the questions, some that I may have missed. We will send you a response anyway to make sure that we do get back to you. But I'd like to thank everybody for joining me. I hope you found this useful. And again, if you have any additional topics that you would find of interest, please do send them to me or to us. I'll be more than happy to put some additional webcasts together for that. All right, so thanks, and have a great day. Bye-bye.